Probably most of you have heard of the term Schrödinger's cat experiment at least once in a lifetime. However, the true details, narratives, and motives behind this experiment remain unfamiliar to many. Welcome to the world of science, where we're about to explore the captivating story and purpose behind this iconic experiment. This is Mind of Science, let's dive right in. The Schrödinger's cat experiment is a thought experiment suggested by Austrian physicist Erwin Schrödinger in 1935 to emphasize the paradoxical features of quantum mechanics. This experiment is directly related to the evolution of quantum mechanics and scientists' effort to understand the conflicting and baffling features of this expanding science. In the early 20th century, multitudes of physicists were testing the limitation of traditional physics theories regarding the behavior of particles at atomic and subatomic levels, as standard physics failed to clarify phenomena such as the photoelectric effect and the discrete nature of atomic spectra. This led to the development of a new theoretical framework to accommodate this observation. Now, let's talk about the definition of the physics theories that make the Schrödinger's cat experiment possible, quantum mechanics. It explains the behavior of particles that are subatomic, less than an atom, and introduces the concept of randomness in physics. The main concept here is a superposition of the particles, which is basically the idea of particles existing in different states at the same time until they are absorbed. The objects in quantum mechanics differ from those in classical physics in that they have characteristics of both particles and waves. Quantum mechanics is described by a lot of people as the hardest part of physics, as we aren't used to it since it doesn't obey the classical laws and is extremely hard to feel. As a famous Danish physicist, Niels Bohr, once said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." Schrödinger's cat experiment was a thought experiment, or in simple terms, a hypothetical experiment, designed to investigate and demonstrate complex or abstract theories, ideas, or concepts. Unlike traditional scientific tests, thought experiments take place entirely in the realm of one's mind and introspection. It frequently entails creating a hypothetical circumstance and then reasoning through the possible outcomes and implications. Schrödinger's thought experiment involved placing a hypothetical cat in a sealed box, along with a radioactive atom connected to a Geiger counter, internal monitor, and a wheel of poison. The experiment is based primarily on the radioactive decay of the atom contained within the box. If the Geiger counter detects radioactivity, the atom decaying, the flask is cracked, unleashing the poison that kills the cat. However, if no radiation has been detected, the cat remains alive. Before the box is opened and observation is made, the state of the atom is described as superposition of both decayed and undecayed states, according to quantum mechanics. As a result, the cat in this situation is officially deemed to be both alive and dead simultaneously. Schrödinger's seemingly bizarre experiment has become part of the foundation of quantum mechanics because it raises the question of when quantum superposition ends and reality resolves into one of two possibilities. Quantum measurement and the observer effect play a fundamental role in understanding the behavior of quantum systems. It basically means that someone or something has observed the quantum system. It makes us take a closer look at how the observation can have an effect on the outcome of quantum experiments, most famously the Schrödinger's cat experiment. In this experiment, it shows the observer effect on a macroscopic scale. When the box is opened, the cat collapses in an alive state or in a dead state, as this occurs only when an external measurement or an observer is applied. This highlights that the effect can have a huge impact on the whole experiment, suggesting that the cat stays depends on the observation. Summing it all up, the experiment has had a huge impact as it helped a lot of people understand the difference between the rules for macro objects and quantum objects. It paved the way for the development of quantum computing, which is pretty hard to explain. However, it mostly uses the concept of superposition to solve problems at an accelerated rate compared to classical computers. Quantum cryptology, metrology, and simulation all made breakthroughs with the help of the experiment. While these applications are still developing, the Schrödinger experiment motivates scientists and engineers to explore the potential of quantum mechanics, and we are sure more applications will be discovered with the help of this experiment.